Hello, everyone. Hello, everyone. Hello, hello. Everybody can hear me okay? All right. Thank you for everybody for coming down to our third Developer Productivity Engineering Summit, DPE Summit as we call it. I'm Ruz, I work for Gradle, and our company, you may or may not have heard about it, Gradle, the build tool. We also are the company behind Develocity, you might be familiar with that product. And so why are we doing this? Why did we bring everybody here today? For us, starting with our open source DNA, community was just always a big thing in our hearts, to bring folks together and magic happens. And the first DPE Summit wasn't really a summit. It was 25 people on a rainy a rainy Tuesday, somewhere around here, and it was 25 of our customers and partners that just came together and discussed developer productivity ideas. Well, hey, this is great, let's bring folks together. And the next one was 300 people, and last year we had 500 people, and we're over capacity this year. Folks still seem to be trickling in. And that was what we wanted to achieve. Get folks here together, share some great ideas, and magic happens. And so thanks for all of you for being part of this community. Thanks to all the speakers and everyone who submitted talks. We had 150 talks submitted, and we had a very difficult decision on how do we pick the right balance of technical talks, high level, new technologies, new ideas into 32 tracks. And so if you talk didn't get accepted, don't be discouraged. There's a lot of great content out there, and we have to make some tough decisions, so please continue to submit. I want to thank my team also there's a huge team behind all of this to make all this happen. They worked really hard to bring everyone together, and big round of applause to my team. And of course, the company for believing in us and believing in this vision and giving us the funds to make this happen. And now about the event. We have two tracks. This is the main room, and we have another room called Gods and Monsters. It's around there, around the corner. And we're also doing lightning talks at around 4 p.m. And how every talk is structured, they're in this 1 hour slot. So if you notice, there's no breaks in the schedule because every talk is around 30 minutes plus a Q&A. So there's a 20-minute gap in between each talk for changeover, for networking, because we don't want you to just consume the content. We want you to network with your peers. And we want you to have that in every designated session instead of just content. At the end of day one, we also have a showdown game show panel. It's going to be super fun, and you all get to vote on the topics and the answers that the panelists gave, so I highly recommend you join that. Happy hour also starts, and we have a little party for you as well. And that's pretty much it for the summit, and I want to introduce Hans to get things started with the first keynote.
Good morning, everyone. So this is my third opening keynote at the DPE Summit. So my keynote today will be straightforward. No neuroscience research this time, no insights into knife sharpening and workers at meat factories and how that relates to software development. And the reason is, we in technology sometime are missing the obvious foundational problems. Maybe because they're not sexy, maybe because it is embarrassing that we don't have a solution for them. And the software supply chain is a very good example for this. And the alpha and omega is simple observability, or the lack thereof, right? And I really mean simple. How many build your organization is running locally in a week, right? For example. And I feel where we are as an industry is still far away from having that simple observability available. I feel like that we're not fully aware of the pointlessness of trying to improve something as complex as the developer toolchain without being able to observe it in depth, right? And while in principle everyone agrees, right, when I talk with them about it, what I still don't see is the urgency to change that. And when I think about why this is the case, is that it might be still too abstract of a concept to create enough urgency to establish that within their organizations, right? And I hope to change that this is something so obviously necessary for everyone that there shouldn't be a keynote about it because everyone has it, right? So this keynote, I want to make it a little bit less abstract, so give you a lot of good ammunition to make the case that coming here next year, right, everyone has that. Everyone has that foundation. So you don't need to make that case for your production environment, right? Everyone has observability in production. But 15 years ago, we were in a similar state as we are with the supply chain observability or the toolchain observability today. No observability, basically. You ask an ops team, how long does it take for the shopping cart to be shown? And the answer was, good question, I would like to know myself. Today you would get fired for not knowing this and for not monitoring it and for not actively complying with an SLA that you, I'm sure, have around that. The urgency for this was obvious. It was directly affecting revenue. But we have a high urgency as well in our space, but the implications are less understood. But this should be the vision, right? This is from a book from Michael Nygaard. The tools, services, and environments that developers need to do their job should be treated with production-level SLAs. The development platform is the production environment for the job of creating software. And who would not agree to that? But this is the talk, where is the walk, right? And when you say, this is great, but I don't know how many builds my organization are running. I don't know how many failures I have per week. I don't know what my dependency download time is, then no, you're not treating it as a production environment, right? So, and from a business impact though, this is a no-brainer once you understand the implication, right? Toolchain observability is either the foundation or a core component for all of those, DX, developer productivity, time to market, DORA, working in small batches, which is one of the key principles of DORA, shift left, security, efficiency, developer culture, all of that, right? So when I look at toolchain observability, right, I hear this very often, right? But then the question is still, why do we need it for, right? And I see 4 major buckets, right? One is governance and security incidents. The other is feedback cycle time. The third is usage insights beyond security and governance. And the fourth is pipeline reliability. And I will talk to all of them. Let's start with security and toolchain, right? How fast and efficient can you address a newly surfaced supply chain vulnerability? And how can you constantly keep evolving your toolchain to have a minimal surface area with modern versions or up-to-date versions to reduce the probability of being affected by one, right? So the Log4j incident was a wake-up call, I think, for the industry, right? It was extremely painful to address. It took a long time to fix the vulnerability, and it took most organizations a huge amount of engineering resources to do so. And that's something to keep in mind when we talk about security. Every security incident when it comes to the supply chain, the tool chain, is also a huge risk for your developer productivity if you're not prepared, right? So currently the primary focus on supply chain attacks is a lot around libraries, right? But it's so much more than that that you need to be aware of. It's your IDE, source control, build tools, build tool plugins, CI systems, CI plugins, artifact repositories. The JDK used to build the software. The machine used to build the software, testing frameworks, mocking libraries, the list goes on. All of those are dependencies, right? If there's a problem with any of those, right, you cannot get things correctly deployed. And if there was a vulnerability in any of those dependencies, the mocking library, the build tool plugin, it will affect your production application, right? So my question is, who of you could easily do a reverse query? Hey, I need to find all services and applications that are in active deployment that have been built with Maven compiler plugin 3.6.2 and has used Mockito X as a mocking library. Who of you could easily answer that question? So that's maybe 1%, right? So who thinks it would be a good idea to be easily answer such a question? Okay, it's interesting, only 50%. So might be morning inertia, right? Yeah, if not, interesting, right? So because if you cannot easily answer this question, how can you easily address such a vulnerability, right? And the reality is, most organizations don't have a semantically rich model that captures that information in real time. And one thing when it comes to toolchain observability that is very, very important, right? It is not enough, and security is only one area where this is important. It's not enough to just capture what are the declared dependencies in some configuration file. What is the dependency declared in a POM.XML or build.gradle or wherever, right? This is not a source of truth, right? Things might get overwritten by some mechanism somewhere in between. What we mean with toolchain observability is always analyzing the toolchain in real time, whatever it is actually doing, right? And capturing the real behavior that happened at that moment in time. And that is the source of the truth, and that is in particular important for those kind of governance and security incidents observability that you need, right? So for me, having this observability, really treating every part of the toolchain as dependencies, being able to find out which of your repositories and which of your deployed applications and services have been exposed to any of those dependencies is a must for any organization at scale, right? So the threat is real and can come from any element in the toolchain, right? So who heard about the XZ utils backdoor from earlier this year, right? And you know the build system was the entry vector, right? They manipulated the build system to create a very sophisticated attack vector, right? And fortunately, it was accidentally discovered. Otherwise, it would have been a major global security disaster. This is happening. I also remember it was years ago when the fifth most popular plugin for Eclipse was a malware plugin. Some decompiler that was also doing malware activities. And yeah, it was running in many organizations like yours, right? Okay, so this is something, it's a no-brainer, right? What we're seeing, there is a lot of attention in the industry right now to solve that, also because of regulatory pressure, right? And the nice thing is, right, this data, once you start collecting it, right, the same reverse queries can be interesting if you want to do a breaking change for a library. Who is using my library version 3.0 because you want to upgrade it to 4.x, but you want to see whom you are breaking, right? Reverse search for the supply chain is absolutely necessary for protecting against supply chain attacks, but it brings a lot of other benefits to make it much more efficient and easier to understand what is downstream so that you can assess if you change X, who is affected by that. So the other big part of observability is feedback cycle time, right? So And that's pretty obvious, but I want to share a couple of examples, right? So once we started doing this at scale with large organizations, for example, one thing that we're seeing that many larger organizations with thousands of agents and 10,000s of repositories, what we're seeing is that 90% of CPU time, easily 90%, is unused. 90%, right? So there would be a typical setup would be that most of the 10,000 repositories, they get a standard CI agent assigned, let's say with 20 cores, right? And everyone is getting 20 cores unless you're a very special project, right? And what we could see is that 90% of those cores are idle, right? So that means builds that need more cores don't get them. They still have a lot of queuing issues, right? They have all these unused resources, but it's blocked by builds, CI builds that don't need it. And number 3 is many builds are misconfigured. They're not using the parallel options. So while they could be much faster, just someone needs to put on a damn parallel switch for your Maven build, for your Gradle build, right? But it's not happening, right? I mean, it's a shit show, right? So, and boy, those CI environments will be so ready for the code growth coming from generative AI. Don't you agree? Yeah. So the good thing is that once you have this data, you're not just able to surface this extreme waste of resources, the data can easily be used to fix it. If you have detailed data about how all the builds are run, you can use this to dynamically assign agents that neither over nor under allocate resources for a specific repository. A Maven project with one submodule doesn't need 20 cores, right? So you can change the parallel configuration for the misconfigured builds. It's so easy, no one is doing it. What's going on, right? So needs to change. And what's going on is no one is aware of it. Everyone thinks, yeah, somehow probably it's not optimally utilized the CPU resources. No one had an idea about the scale. And once you do this, the results will be spectacular, right? You can increase your CI capacity by 10x possibly. So that brings me to another topic. CPU and disk I/O are such fundamental resources and constraints for running builds and tests. Okay. No, a little bit background noise, but Trish, I have a lot of background noise from the back room. Thank you. So what we see over and over again is people wonder why their build is slow, right? And they come to some wild conclusions. We had one incident, I guarantee you, 1,000 submodule Maven build, right? People were thinking about a year-long build migration because their build was slow. But it turned out to be primarily a disk I/O issue on CI. And once we surfaced that information, it was a very easy fix, right? It was a fix within a day versus multiple years of a lot of engineering resources. And what we're also seeing all the time, people doing migrations from one CI product to another, and then comparing apple with oranges because disk I/O is not the same for the different CI products. It's just when you don't have the basics, it's so hard to reason about anything, right? And CPU and disk I/O, very important. So we are very excited that in the latest release of the Velocity, we have added CPU, memory disk, CPU, memory, disk I/O speed, network profiling information to the timeline view of build scans, right? And another examples, we had this one org, and it's an interesting one because this is about culture, right? With this one org, where their builds were extremely slow on a Saturday. Usually Saturday is the best time to get anything through the pipeline, right? So this was the exception, right? And the developers were completely confused by that. And by looking at CPU time, we could see that the CPU load outside of the build massively increased on Saturday. So it turned out that this was the time when a lot of updates were applied. No one in development knew about that. And in this case, there's nothing to improve. That's just how the organization works. But it has increased the trust and the predictability into the toolchain by the developers. This is so important. When the developers don't trust the toolchain, right? When it does whatever it wants, there's no explanation, no one knows why, right? This has major implications on the behavior of your developers. It deserves a whole dedicated presentation, but I claim that a predictable toolchain where the phenomena are understood, right, is important for a healthy development organization, right? And it has many, many negative effects if you don't have that. So next thing I want to talk about, ephemeral CI. I was always fascinated how ephemeral CI was introduced, right? So you make a huge disruptive change to a production resource, which is mostly developers, right? Organizations paying, the large organizations, billions or tens of billions of dollars, right? Just in direct cost, right? And you would think, before I make that change, let's measure the impact, right? Let's measure the impact it has and see whether it's worth it and how we can mitigate it. Well, we don't have the data. Just push the button, fire and forget, right? No responsibility, no accountability, right? And that's exactly what happened across the industry, right? And I'm sure this has cost the industry tens or hundreds of millions of dollars over the last 5, 6, 7 years. But it's dark cost, not measured, not quantified, so what? And now we're starting to surface and quantify some of that dark cost. And one obvious aspect of ephemeral CI is the increase in dependency download time. So everyone knows it, right? Who is excited about their dependency download time? This room. Yeah. But no one is able to quantify it. I cannot tell you how many booth conversations. Yeah, we introduced ephemeral CI. Dependency download time is so long. And then my question was, how long is it? Well, don't know. I mean, every conversation went like that. I'm talking about, that includes very companies that are advanced and definitely considered advanced at the engineering level, right? So what we have been able to measure across many large organizations is, I think, remarkable. 30 to 40% of all CI build time at large organizations is spent downloading dependencies. 30 to 40%, right? And that is one explanation for the idle CPUs, obviously, right? So now you at least can quantify, hey, this is no longer anecdotal, this is quantifiable, right? And you can make a business case. So a big part of useful toolchain observability is to give you the big picture, but then also allows you to drill in to find the root cause, right? So you want data that tells you, is it a problem of network speed? Is it a problem of the number of network requests? Is it a problem of getting a lot of 404s from out of factory? There are quite a few dimensions to dependency download time. And if you can break it down, if you cannot break it down, you cannot fix it, right? So what we have seen in general, that for CI builds, the problem is not so much network speed, but the number of requests to the binary repository. So the solution is to reduce the number of requests, right? Faster network will not help you, right? For local build, situation is different. So we're working on a solution for that, but it's a huge problem. And one thing I want to mention in this context, when we talk about toolchain observability, we have so far focused only on CI, and most organizations only focus on CI. They have shitty observability on CI, they have no observability for local builds, right? And so the local experience is like, I don't know, being in some private prison, some part of the world that no one pays any attention to, right? And then everyone wants to shift left. Great. So, and it's not just about dependency downloads, right? So I never forget that we worked with an insurance company and looked at their builds and test times, and they only looked at CI build times, said our CI build times are great, right? A minute, 45 seconds. Once we started collecting data from developer builds and tests, we found something interesting. We saw local builds took more than 20 minutes, right? For the same project. So digging in deeper, we found that those builds come from developers that work from home and use a network share for the build output directory. Okay, that happens, no problem, but it's good to know about it. For the developers, it was normal, no one complained, and I guarantee you, wherever we look, what is happening with your local build experience to your developers, it's once you surface that, it's like, oh my God, oh my God, oh my God, oh my God. And a lot of that is easy to fix, right? But you need to know about it. And it's not enough to fix it once, right? I mean, it needs to be monitored. It's your production platform, right, for creating software, isn't it? Right, so another good example is people using a remote build cache for their local builds, right? Great, right? But at this organization, it was an open source project in this case. What no one realized was that the cache for most of the local developers was misconfigured. So they were getting exceptions, cache node not found. So, but the build doesn't fail, right? Gradle build tool tries 3 times, and then it just runs the build without a cache. So everything seemed to be fine, except that their potential cache savings were like terrible because hardly any local build was using the cache. So without observability, using any back-end technology like build caching you're missing out a lot on the potential savings and possibly introducing negative savings. So again, shift left without local toolchain observability, forget about it, right? It will be just talk. So let me move from feedback cycle time to usage insights. So when we talk about usage insights, sometimes people say, oh, it's nice to have, right? So I mean, it's a must-have for security, but I think it's a must-have also beyond security. So one of my favorite examples are migrations, right? So developers do a lot of migrations, right, from one library to another, major version updates in libraries, CI systems, build tools, etc. And with migrations, you always want to do the following, right? Figure out who needs to migrate, what is the progress of the migration, and are there any issues introduced by the migrations? I mean, it's pretty simple, right? So, but what do people do nowadays, right, if they don't have that? So typical example is CI migration. We like a lot of companies that move from CI product A to B, right? So, and because they don't have toolchain observability, what they do is they measure everything by project. So they measure the progress of the CI migration by how many projects have migrated. This is not a good measure, right? Because you have tons of zombie projects, you have very big important projects, you have very small projects, and you might think, hey, the migration is going great, right? We have achieved, let's say, by July 7, 60% migration, right? But when you look at CI build volumes, only 15% migrated, right? And that is a problem we see all over the place. You cannot measure properly progress of any kind of migration. So, and that is often the reason why some migrations are not even started. Some migrations are kind of, people are frustrated because they think they're not making progress while they actually made a lot of progress. And then the other thing is quality of service, right? So are there new types of problems for the migrated usage? And most organizations are not able to answer this. They just say, we do this migration, and then, like ephemeral CI, fire and forget, right? That is the new reality. Might be as shitty, might be shittier, might be a little bit better than before, we don't know. So I want to share a story that underlines that. A large organization is in the process of migrating their CI product from A to B. And I was talking with their very competent CI team and CI engineering lead. And he said, well, quality of service doesn't matter. And I was like, why doesn't it matter? Well, the migration is mandatory by executive decision, right? So developers don't have a choice. Everyone has to be migrated by the date X. My ass is on the line just by the numbers of how many projects have migrated. Doesn't matter, right? Build time's 10 times longer. No one will get blamed. If the projects are not migrated, I will be in trouble, right? So I usually don't play C-level people, but so, and lack of accountability, right? I mean, the CI could be 10 times slower. People wouldn't even know, right? They don't even do the comparison. So you have to get your incentives right? right? And all I can say that this is not how a mature industry changes their assembly line. I think we all agree on that. It has to change. And by the way, from a DX experience, it's of course very shitty for the developers. Another reason why you want to have usage insights, most organizations don't know how much a tool chain is used, right? And you want to know this for your educational offerings, for possibly phasing things out, right? You want to know where to focus your developer productivity initiatives on. The best people have is analyzing the source repos, right? But that is absolutely not sufficient, right? You need actual usage data. How often is the tool chain used? What are the problems? What is the quality of service? What are the failures, right? What is the return on investment for making certain tool chain usage faster, right? Even it's so obvious, right? Any DX team needs this, and no survey can substitute for this. Finally, why you want usage insight is toolchain consolidation. I think Etienne is giving a talk about this tomorrow, I think, about gaining cross-project build insights. And that it will be one part of the talk. The version spread we see in the toolchains once observability switched on is terrifying, right? The JDK versions used in local development environments, the range is like, wow, right? And it's terrifying, right? It's a security concern, it's a reproducibility concern, and it will definitely lead to hard to debug problems, right? A lot of that is very easy to fix once you know about it, but you need to know about it. One of my favorite topics, right? Pipeline reliability. This is a super interesting and complex topic. So providing the service as promised is a key SLA for your production environment. And this is proactively managed with whatever application performance management practice and product you're using. The reality for the path to production is that the mindset is reactive, right? Developers have to run into failures related to the pipeline. They have to file an issue, and then they get addressed, right? There's no proactiveness wherever I'm looking, right? Unless maybe all of CI is down. Okay, then probably there's some proactiveness. But anything a little bit more complex, no. Developers have to run into the problem, then complain about, or then file an issue, complain about it, right? And then it might get addressed. So, and that is something you want to turn around completely. And obviously, observability is key to this. It goes beyond the scope of today, but this is one of the biggest challenges and biggest adversaries of a good developer experience is pipeline reliability. And it all starts with knowing about your failures and flaky test and what causes them. Again, all starts with observability. Most organizations would have no idea what the different failure categories are on CI, let alone for local builds, right? So I'm almost at the end. So having seen the impact observability is making to organizations, right? For example, with our product, has made us even more convinced about its importance. So our customers have been asking us to extend our support to other tool chains. So we've been listening and are super excited to announce the velocity support for NPM and Python coming in the first half of 2025. Yep. So please, everyone, do your homework. Make toolchain observability a priority for the local and the CI environment. Do no longer be embarrassed by not even knowing how many builds your organization is running. Right? It will be a gift that keeps on giving. It will create trust between the infrastructure and the developer organizations. It will lead to rational decision-making, impact-driven decision-making, enabling you finding low-cost, high-reward opportunities to improve the developer experience and the productivity. It will be transformational for all of your DX efforts and your development organization as a whole. Thank you very much.
Thank you, Hans. Good morning, everyone. I'm Trisha G. I'm a developer advocate at Gradle. I am your host for today in this room in Ride. So I'll be introducing all of the speakers and so on. So now I have to remember what I was going to introduce them for today. The next keynote follows on nicely from what Hans was saying. It's about how we measure developer productivity, which means getting an understanding of what it means to be a productive developer. I'm going to introduce the speakers, but they're not there yet. So now I have to do a small song and dance in front of here to keep you all entertained. So while we're waiting for that, don't forget there is an app for the conference, the Hoover app. So take a look at that. The agenda is on there. There's also there's a bunch of groups and conversations that can be had. You can kind of get together with like-minded people. Sometimes there's some community meetups and stuff over lunch and things like that. So do download the app because there's loads of interesting information on there. So without further ado, please welcome Dr. Sierra Jaspin and Dr. Colin Green from Google.
Hi there. I'm Colin Green. I'm a user experience researcher at Google.
I'm Sierra Jaspin. I'm a software engineer at Google. And we co-lead a team at Google that is an interdisciplinary team of software engineers and UX researchers spanning from a wide variety of fields. We've got people with degrees in computer science, statistics, economics, public policy, and cognitive psychology. And what we do is try to understand how to make developers happy and productive. And today, we're going to share with you a little bit about our team's approach.
We're going to start out a little bit philosophical. This is a quote I like. All models are wrong, but some are useful. George Box is a British statistician, and he started saying and writing things like this in the 1970s. There's two things that I like about this quote. He was talking about statistical models, but really the quote applies to all kinds of models: theoretical models, statistical models, measurement models. And I like this quote because it compels us to think about two things when we think about models. One is it encourages us to think about simplicity, parsimony, right? If all models are wrong, then there's no reason to stress or to over-worry about making your model too precise, accommodating outliers, accommodating edge cases, overfitting limited data. Simplicity is better in these cases. The other thing it encourages us to do is to talk about how our models are wrong, right? The obvious follow-up question when you say all models are wrong but some are useful is, how is this model wrong? And is the way that it's wrong important to me? Does it matter? So this is something that George Box called worrying selectivity. And he talked about it in the context of models that omit critical matters and therefore become less useful as a result. Worrying selectivity. Now, George Box wasn't the first or only one to talk about this concept. This is a quote from Gerhard Rasch from 1960. He's talking about modeling as well, same kind of principle. What I like about this quote is that it emphasizes the importance of the modeler's knowledge and the modeler's choices as drivers of the utility of the model. So what you know as a modeler, as a measurer, can influence whether your model is applicable or not. So I know this is not a statistics conference. I know this is not a philosophy conference. Why am I talking with you about these abstract things about models and why models are wrong? Here's why.
So what is the best metric for measuring engineering productivity? Quick show of hands. How many of you have had this been asked to you? Yeah? Well, we're going to talk about this one. We get asked this question a lot, and we do spend a lot of time thinking about how to measure developer productivity. And of course, when I say measure, what I mean is how do we build a model of engineering productivity? And as Colin mentioned, any model we build is going to be wrong. So today we want to think about how to measure engineering productivity so that our models are not wrong in problematic ways. We want them to still be useful and applicable to the problems we're trying to solve. So with this question, and with a lot of questions, there's a couple major problems here. The first is that when we build a new model, we want to make sure it's explainable. This gets to the parsimony question that Colin posed to you. We want to make sure that when we have a metric and it changes, that we understand why it changed, and that we understand how to make it actionable. So we have to make explainable metrics. We're actually not going to talk about that today in this talk, because that's a bit more about metric design. But we are going to talk about is the question of, are we omitting things in the metric? This idea of worrying selectivity. We need to make sure we select metrics that are measuring all the major aspects of developer productivity and covering the whole space of it. So We'll start with the problem that a single metric does not acknowledge the inherent trade-offs that must be evaluated. And this is actually the problem with that previous question, right? It implies that there is a single metric, and that means we're going to have worrying selectivity there. So first, we argue that you have to measure across the space of developer productivity. When our team, we use speed, ease, quality. And to really emphasize this, I have a quote here, actually from Colin, that he likes to use in meetings. I can improve developer velocity by removing code review. And this is how we emphasize this point at Google, because code review at Google is sacred. Like, nobody would ever get rid of code review. That is the final bastion of checking for quality. So it makes the point to people, though. We have to be able to weigh out velocity, quality, and ease. So we think about speed, ease, and quality at Google. Some of you probably use the SPACE framework. That's fine, too. Honestly, I don't care what framework you use. Use a framework that covers the full concepts around productivity and the inherent trade-offs within it. So this idea of using metrics that cover all of these is really the underpinning of our approach. So put another way, we want to avoid worrying selectivity by checking each of these things that we're trying to measure.
The other way we think about worrying selectivity is when we think about the ways that we measure and the behavioral methods that we use to make those measurements and to collect data. So for example, we're going to talk about the way we combine logs data or logs-based metrics with other kinds of methods to measure sort of a more holistic picture of productivity. Using multiple methods is useful for a number of reasons. One is that it allows you to measure more things. Right? Some things are just not easy to measure with objective metrics based on logs. Developer satisfaction is a great example. I can't look at your logs trace and understand how satisfied you are in your role as a developer. Okay? But there are other things that might fall into that category. The other thing that we do is we use multiple measurements to assess validity of our measures. So as we'll talk about in a few minutes, we're using logs in many cases to build a metric that tells us about productivity, but we want to constantly be questioning, is that the whole truth? Is that the actual truth? Right? So when we use multiple methods and we make multiple measurements, we can explicitly compare those things to each other, and when there's a discrepancy, we can dive in and say, is there something substantively wrong with either or both metric, or are they just telling us about different facets of this same construct? And then finally, when we combine methods, particularly when we incorporate behavioral and qualitative methods into our research, that helps us to understand where we might have blind spots. So objective metrics are great, but if you're not measuring a thing, it doesn't show up in your objective metrics. Sometimes when you run a survey or do an interview, things spontaneously emerge and give you some more context on why something is happening, not just how much is happening or how fast it's happening, et cetera. Okay? That context is important. And actually, the last point there about knowing the context is important to the final reason that we do sort of have a preference to not use single metrics for productivity. That's Goodhart's law. So I've actually summarized it over there, but the top of the comic here, when a metric becomes a target, it ceases to be a good metric. That is the essence of Goodhart's law. So how you measure matters. And when you put a measurement in place for productivity, you're also potentially putting incentives in place. This is probably not a new concept to any of you. If you wanted excessively verbose code, you should absolutely set up a productivity measurement that rewards more lines of code submitted per unit time. You will get verbose code. Okay? So those sort of undesirable incentives, they happen in human systems. It's not about malice or mischief on behalf of developers. It's just about the way individuals, teams, and organizations respond to the incentives you put in place. And when you measure productivity, you're putting incentives in place. So just to recap, don't measure just one thing. Measure all the outcomes that you care about. For us, it's often speed, ease, and quality. You might have a broader set of things. You might adopt a different framework. But measuring across many constructs to understand that trade space of productivity is really critical. You don't want to just take out code review to get some velocity. That won't work out well for you. Measure things, if you can, in multiple ways. Look for the discrepancies. Look for the places where your measurements don't agree. And worst case scenario, you're going to find out that a construct that you're measuring is maybe a little bigger than you thought it was. Okay? And then finally, be careful of the incentives that you create. You don't want to put an undesirable incentive in place by having a narrow view of how you measure productivity.
So for the rest of this talk, we're going to start with actually telling you a little bit more about how we actually measure, kind of our key parts here. And then we're going to go into a couple deep dives showing examples of when we use the measures to actually make real changes at Google. So we use all of these techniques, But the ones we use the most critically are developer activity logs, the diary studies, and the longitudinal survey. So let's do a little deep dive into our dev activity logs and our diary study first. So what is in our developer activity logs? All of these lovely things. We have a really unique opportunity at Google. Because we actually build our own developer tools, that means we can then instrument them and pull in a huge amount of logs. So our team has every single time a developer clicks a button in the code review tool, we have every file save, we have every time they do a test run and the results of it, we have every command line tool, every time they look at documentation. This provides us a really rich picture of the development environment. Additionally, we do pull logs from other places. So we have things like their email data. Now, I want to be really clear about what I mean by that. I do not want my colleagues' email contents. I do not want the subject line. I do not want to even know who he's talking to. But what I do want is when someone is in email. And that becomes important, and you'll see that later, because it lets us ask questions like, how long will a developer wait for their build before they context switch to email? So the timestamp is really important. So we do pull that type of data for that purpose. And we're very careful to not collect metadata for those tools with mixed-use purposes. We're also pulling information about people's things like level and what team they're on, what programming language they use. That's important for us to understand the differences between different needs of developers. Some developers might end up in weird corner cases of our developer tools more often than others, so we need to be able to understand all their different experiences. Now, I want to really emphasize here, we do not use any of this logs data for performance evaluation, and we always present it in aggregate. This gets back to what Colin was talking about Goodhart's law. If we were to use this data for performance evaluation, we will inevitably result in developers trying to emphasize one metric over the other and have some undesirable incentives. And our goal is actually not to say that developer A is better than developer B. Our goal is to improve the tools, the processes, and the frameworks so that we improve the developer experience for everybody, regardless of where they're at, whether they are a fresh junior engineer straight out of college or if they are a 20-year veteran. Everyone's experience should be improved. So how we actually do this in practice, we're starting with a pile of logs we pull in from all these different places, standardize it, and then we sort this based upon each user and time. So we have for each developer, we have kind of a timeline of what they have done in all of these different tools as they're bouncing between them. We then group and cluster these based upon the type of task that they were doing and, again, time. So if we see a developer doing a code review on one change list, and then they switch to doing a code review on a different change list, we're going to group those into 2 different sessions. Additionally, if we see a more than 10-minute space between 2 events, we're going to say, OK, even if they were on the same task, the developer probably stepped away from their computer. Maybe they went to lunch. Maybe they went to get coffee, go to the bathroom. But we're going to group those into 2 separate sessions. And what this gives us is a really rich picture of a developer's day and allows us to create some really interesting metrics based upon this. Now, some of these metrics are pretty mundane. We have things like how much time people spend in meetings and how much time they spend in their email. But this blue circle over in the upper corner here is active coding time. To get that, we take all of our sessions where a developer is editing code, and we cluster those together and say that whole session then is active coding time. This means that we are capturing not just the time the developers in their IDE, but also the time where they went to the code browser or looked up their test result or looked up documentation, and then they came back into their IDE and kept coding. We're capturing that fingers on keyboard time in service of the commit they're making, but we're not including things like weekends and evenings and the time they spent working on a different commit. Now, these are all proxies of a developer time. It is a model, and as we said before, models are wrong. So the question is going to be, how do we know this model is not wrong in ways that will be problematic for us? So the way we do this is actually using a diary study. What we'll do is periodically we'll actually ask for about 30 to 50 software engineers at Google to volunteer their time for 1 to 2 days. And during those time periods, the developers will write down everything they did. maybe every 5 to 15 minutes. And we get this kind of log of those couple of days for a developer, and our teammates go and then code up, okay, this developer said they were doing a code review on this change list, and this developer then said they're working on this change list, doing some coding. They were then responding to somebody's comments, and we code these up, and we can now compare those diaries with our actual logs. And this is an example of one particular diary that we had. Now, we can then visualize the data and see that. We also use some agreement metrics, which you can see across the bottom. And these are a bunch of different kappa scores to understand the amount to which the diaries and the logs agree. Now, in this case, we're looking for agreement because neither of these are really perfect, notice. The logs can lie. They might be incorrect in some way. But human memory is also fallible. So we're looking for not saying either one is perfectly true, they're both models, but we're looking for, do they mostly agree? And if we're seeing good agreement, we say that, okay, now we know this particular metric is representing the concept that we really wanted to get at.
So as Sierra was mentioning, we do this validation exercise to make sure that we're interpreting the logs correctly, that our heuristics aren't like wildly off, and that we have these two lenses on the reality of what's happening in a developer's world. And the logs-based metrics are useful for a number of reasons. One thing that is great about them is that we get those data, once we've validated our metrics, we get those data for approximately everyone at Google, right? Lots and lots of developers. So the coverage is really good because we're collecting those data in the background and we can see what's happening for everyone. That's awesome. We also get like literally lots of data points. There's just a lot of these data points when we look across all developers at Google. So we get enormous statistical power. Even when we do things like break activity down by mobile versus non-mobile development, or people who are doing ML things versus those who are not, or if we filter down and say like, just show me people who are using a specific feature, a specific tool, a specific framework, we still have enough data to say meaningful things and do meaningful analysis of those things. Okay. Finally, the thing I like about logs data, and as a person who does a lot of the behavioral studies and oversees a lot of that side of the research, where we have to ask developers to give us their time, where we have to ask them to keep a log of their day, we have to intrude upon their work. I like the logs because they're passively collected. Once we've validated these metrics and we've deployed them, we're getting those data all the time, and engineers don't have to do anything. It's actually invisible to them. So those are all really big strengths of having the logs data, and we rely a lot on our logs-based metrics to do some of our analyses. But they don't give us everything. And as Sierra mentioned, the other piece that we do to make sure that we completely understand productivity as much as possible is a longitudinal survey. So we run our engineering satisfaction survey, ENGSAT for short. We run it quarterly. We've been doing that since about 2018, so we're, I think, pushing 7 years now of data. It's been a long time, actually, to run a survey. Every quarter, we survey about 1/3 of Google engineers. Actually, I should say we invite 1/3 of Google engineers, and then some of them actually give us their data. We have to spend some time doing things like non-response bias analysis and mixed shift analysis so that we don't have a subset of engineers who are particularly survey willing, tainting our data, or pulling it one direction or another. But we ask a whole bunch of questions in ENGSAT. We cover a wide variety of engineering topics. Some of the things we cover are really about the triangulation that Sierra was referencing before. So for example, we ask developers how satisfied they are with the engineering velocity on their project. We're trying to get a subjective survey-based measure of eng speed as a way of triangulating with other metrics like active coding time or throughput or whatever we're doing from the logs. So that triangulation with the survey is one really useful application of this additional method of measurement. But the other thing, and I mentioned this slightly before, we can use the survey to measure things that we either can't yet or maybe can't ever measure with our logs. I mentioned engineering satisfaction, but we've had other things that we want to get at that we're not sure we can measure from logs. Flow is an example. So you know that it's important for a developer to be able to reach flow, that the tools that they have, that the infrastructure they work with influences their ability to reach flow. It's hard to figure out how to extract that from logs to know whether a developer is in flow or not. So we ask people how frequently they achieve a state of flow or high productivity in their work. It's not perfect, but it's more than zero information. Similarly, we've asked people about technical debt a fair bit. Expert judgment of where technical debt exists and what shape it takes is actually the best indicator we have right now of how much and how bad and where our technical debt is. Now, we also ask about these things in the hope that we will eventually objectively measure them in some other capacity or measure them at scale. And in fact, we've made some nice progress, I think, on flow, using the logs, using some ML models, and trying to understand when developers reach flow. So because we had survey data, we were able to use that as an input to building a model that actually reflected from the logs data when engineers achieve flow or focus. Technical debt, we haven't made as much progress on those objective measures. We've tried. I think we have more work to do. But for now, we actually rely a lot on our survey data to understand technical debt. So there are some merits to running a survey in terms of what you can measure, how much you can measure, and how you can use the data. Surveys are also quite agile. Now, make no mistake, one of the easiest things you can do is run a terrible survey, right? It's even faster to run a terrible survey than it is to run a good survey. Taking the time to build a good survey, well, it takes expertise, it takes time, okay? But if you have that capacity, surveys are quite agile. I'll give you an example. When everybody went home in 2020, there were lots of leaders going, uh-oh, what's going to happen to productivity? Like, how is this impacting our engineers? Yes, we have a lot of logs-based measures. Yes, we had survey data, running back and forth across the pandemic. But when it came time to understand how developers' productivity, satisfaction, workflow was being changed, we were able to add a question to NGSAT right then. Right? March 2020, people went home. I think we ran the survey less than 3 months later, and we asked, hey, how's it going at home? We were able to ask about pain points, ask about things that were working. So the agility of the survey was really important. It's not a replacement for developing logs-based metrics necessarily, but it gives you the ability to start gathering information quickly where maybe you wouldn't be able to do that in terms of observability or instrumentation in your tools. Now we're doing the same thing to respond a little bit to AI and the developer workflow. We want to understand what people perceive as working and not working in AI for their developer tools. And so we've started to add questions to our NGSAT survey. We're also approaching this from a logs-based perspective, but NGSAT lets us get at the substance more quickly and gives us some of those surprises that we were hoping to find.
So let's go into a couple of concrete examples now of how we utilize this. One of the questions we got asked early on, and I'm going to guess how many of you have been asked what kind of magic number there is to get your build latency under? Who wants to know more about build speed here? Yeah. We got asked several times, is there a magic number? If we get builds, is that like a step function? If we get builds under a certain speed, will developers all magically become faster? And there's actually a lot of blog posts claiming this. I've seen under a second. I've seen one blog post that claimed 8 seconds. I'm not sure where they got that number, but 8. I've seen a minute. And there was this belief that if you could just get all the builds under this one time point, that everything will be faster. Developers will stay on task and they'll keep working. So that was the question we looked at, and we looked at this using both our survey data and our logs data to see, for engineers, is there any difference between the engineers who have generally fast build speeds versus generally slow ones? And we found actually through that data analysis, there's not a step function. Every improvement you make to build latency will in fact improve developer velocity. This is in some ways a little disappointing because there's not a target, but in other ways it's very freeing, because you can make literally any improvement and you will improve developer velocity. So we let this be known to the team that runs all of our build systems at Google, and they actually came back with us with an interesting problem that they had. They had a couple of modest improvements that they could make to build latency. Now, these weren't the type of improvements where it was like you were going to have your build latency. If it was like that, it would have been super obvious. Everyone said, yes, go do it. These were modest improvements, and they came at cost, either cost of engineers to improve the compiler or a cost of faster machines. And the question was, is this improvement we're going to make, a modest improvement, worth the cost that we're going to have? So we actually ran a covert A/B experiment. We enrolled a portion of our engineers into a system where all of their builds would be run by the faster machines, and we did not tell them that. That just happened. And we were looking at whether this would actually impact their build speed and also, though, all their other metrics about satisfaction and how they behave. What we saw is with those modest improvements, in fact, we saw modest gains on things like NGSAT. So our NGSAT data is up here in the corner. We were seeing like a 5% improvement for these engineers in the experiment group to their reported satisfaction with build latency, their reported personal velocity, their overall productivity. We saw increases in all of those. And again, these engineers had no idea that we had mucked with their build speeds. All they knew was they were taking NGSAT like they always take NGSAT. Additionally, we saw behavioral changes. That was fun because actually the behavior changes were a couple months delayed because it took engineers a little time to realize that things were faster, and they started adapting and coming back on task just a little bit faster, which meant they had a few more iterations every week to that build, edit, test cycle. So we saw this in a lot of the cases we were looking at. And then this actually led to multiple improvements in build latency. We were able to take this data back to the team and say, hey, here's the benefits you're going to get. You decide, is it worth the cost? And they did decide it was and rolled it out to the entire company.
So one more example of how we've used this sort of like multiple metric, holistic view of productivity to make a decision at Google. I'm going to talk about readability a little bit. So readability is a practice at Google where you, as a new engineer, if you're not already certified with readability in a language, you get extra sort of coaching and feedback about your code in that language until you have demonstrated that you can write with the consistent style, the idioms, and the sort of conventions that are common at Google. So if you're a new engineer at Google and you wrote some code in C++, that would go through readability review, where somebody would check it for style and convention. Eventually, you'll get enough coaching and you'll submit enough C++ code that you'll be readability certified, and then you don't need that extra review anymore. Okay, so it's a learning experience, it's a coaching experience, but it's also a process that adds essentially friction to submitting code. And this practice has some controversy at Google. So people have asked, is it worth doing this? Do we get as much out of it as we pay for it in terms of productivity costs? And so we were asked to try as best we could to quantify the costs and benefits of readability. And we did this by looking across a number of different data sources, including our logs and our survey data. So one of the places we looked was at surveys from people who'd actually gone through the readability process, surveys that were run by the readability team. And there were a lot of reflections there about what they got out of the process, things like mentorship, training, familiarity with disparate parts of the code base, and also some of the pain points, like, I feel like I'm being hazed a little bit. There's a lot of friction here. I'm being held to a standard that doesn't make sense to me or is unfamiliar. We also looked at sort of the productivity impacts in a very concrete way. So this chart over here on the side is showing the amount of time that the author and the reviewer of a change invests in reviewing a change before, during, and after the author has been given readability. So the critical thing here you can see is that the amount of time required of the author and the reviewer before readability actually gets worse during the process of obtaining readability. So when you have that extra review, that extra coaching, that extra mentoring going on, everybody's spending more time to get the change through. But critically, after readability is granted, that time is going down not just below where it was during the process, but below the baseline from before. And these numbers are corrected for like the number of reviewers, the size of the change, et cetera. So we're controlling a lot of additional variables here. So that gain from before to after, I think we ended up figuring out that it pays back what you invest in time in something like 18 change submissions. So after 18 submissions, you've paid back that invested time. Okay, so the speed is here. We also looked at NSAT. We looked at people's satisfaction overall, their judgments of velocity, et cetera. Now, this was a really critical piece that I think nobody had before, but readability is not specifically about speed. However, having this look at speed, in addition to things like what did engineers get out of the readability process as benefits, what did they like about it, and what were their pain points, that gave a much more complete picture across sort of engineer learning, speedies, and quality than we had before when we were trying to decide about whether to retain or eliminate the readability process. And I guess the punchline is that readability is still a thing at Google. So we wanted to make sure that we finished our talk by talking about what you can take away from it. We don't want to just be up here talking at you. So I'm hoping that you can take some things away just for your experience here at DPE. I really want to give you George Box's quote, right? So if you can keep that in mind while you learn all these new things over the next 2 days, I think that has a lot of utility. Keep in mind, all models are wrong. So you're going to hear a lot about different ways to measure productivity, different ways to think of it, different models for what's going on with engineering. They're all wrong, and I'm not maligning them. Ours are wrong too. But it's a useful sort of intellectual tool to say what's being measured, what's not being measured, what trade-offs might be hidden in what's not being measured. Would I draw a different conclusion if I measured things differently? And then again, not to be completely negative, ask whether it matters how the model is wrong. Is it a blind spot that matters, right? Do the shortcomings of this particular model matter to me at all to answer the question that I'm posing? And is it worth measuring differently or in another way? There's cost to all measurement efforts. Instrumenting, adopting a tool, running a survey, these things have costs in terms of time and effort. And so you should be asking whether what you gain from that additional overhead of doing the measurement more completely actually buys you the right answer. Okay, and then finally, Don't forget about your goals. You should be thinking about what is the intent behind a measurement model? What is the intent behind a metric that you're putting in place so that you can keep in mind things like incentives, utility, and undesirable incentives.
When you leave DPE now, too, one of the questions you might think about is like, I've got all these new ideas from this conference. What am I going to do when I get back to my company? And that really depends on, in fact, what size of company you're at. If you're at another large company like we are, you can do like we did. You can staff the 20-person multidisciplinary team where you're connecting logs data and survey data and diary studies all together. If you go to the other extreme, though, the type of really small company, our argument has always been, look, if you can fit all your engineers in a large conference room, don't bother measuring things. It's actually probably not worth your time to be over-optimizing and over-measuring. If you can fit in a large conference room, get in the large conference room and have a discussion about what are the current pain points, what is the best way we think we can improve developer productivity, and trusting the team as humans to be able to figure that out. The hard part's that fun part in the middle where you've got a company that's you can't afford to have a 20-person team, but you also don't fit in a conference room. And in this case, we actually recommend really strongly using surveys, because surveys still give you that kind of broad view of what do the developers all think, and you can ask across the concepts of speed, ease, and quality, but relatively to doing all the logs analysis, it's cheaper. And then if you need to, you can deep dive into logs analysis for just the problems that you know you want to attack. You can use the survey to say, okay, what are our big top 5 problems? Let's pick one problem we're going to work on now, and then we'll make logs as necessary just for that one problem. In all these cases, though, regardless of the size of your company, we again encourage you to think about, like, what is your goal? We encourage people not to do performance monitoring, but again, to actually try to improve productivity, triangulate across speed, ease, and quality, and really, like, are you successfully identifying what is the largest and most tractable problem you can solve? So we'll leave you with, we've got a couple of related research papers here. There's more than this. These are just some of the ones that we mentioned, some aspect of this in this particular talk, but we have a IEEE software column called Developer Productivity for Humans that has little short snippets of a lot of the work that we've done over the last couple of years. And if you have any questions, you can contact us at these email addresses. Thank you so much.
Thank you for listening.